Hey guys, so I want to make a quick video. I know that I've had several students asking about chapter 7, especially with confidence intervals. And I think that what happens with that is so much of the chapters 1 through 6 that we've covered so far is what we call descriptive statistics, the making the graphs, the histograms, all that. And we're just kind of making stuff to show data and display data. And chapter 7, the confidence intervals, the first time we have what's called inferential statistics. We're taking a sample and making a decision about a population based on that sample. So keep that in mind. I wanted to show this. I think that in confidence intervals, it's easy to get really bogged down on that super intense formulas, this 1.645, there's all these other numbers, and we kind of lose sight of what's actually happening. So I want to give us a good foundation of that, because when we get into the hypothesis testing next, it's going to make a lot more sense. Let me flip over cameras here. Now, this is kind of a made-up example. I wanted to give us an idea, and this is one that I discussed with a student yesterday on the phone. But for everything we're going to have here is where we have P and Q. P is the probability of what they call success, and I'll talk about that here in a second. And Q is failure. This is what's called a binomial. Either an event occurs or the event does not occur. And I do not want us thinking that success means good. This just meant that whatever event we're talking about occurs. Failure means the event does not occur. I know the examples that we see in the homework are, one of them is where it talks about at a restaurant, the number of times an order is messed up. Messing up an order is bad. But when it's asking at what's your probability that it's going to mess up, that is going to be your success at that point, because that is an occurrence of when somebody messed up making an order. I think there's another one on light bulbs, and it asks the chances of getting a defective light bulb is make a 95% confidence interval. A light bulb being defective is not a good thing. I want my light bulbs to work, but if we're trying to look at what is the probability that the light bulb is defective, that is occurring, that it's defective. Do not think that occurring means good or bad. Do not think that it means success or failure, and the nature of us thinking of that is good or bad. Where I want us to think now, because this is one that in the season, and I'm sure we've all seen it all over the news and social media, I'm going to put and assume right now that we're only talking the two parties. When we look on the news, and I know there is that degree there, the unknown, also the third parties, everything else, I'm going to for right now say the success, okay, the occurrence that we'll call P is Trump being elected, 47% of the voters. And I'm making these numbers up. I have nothing to base any of this on, but I wanted to get this foundation. P and Q add up to 100%. So that means that if 47% of the voters voted for Trump, that would mean that 53% of the voters voted for Biden. It must be the case that either an event occurs or does not occur. The binomial must occur for the proportion. Now, what we want to also think of is we're used to, moving the two decimals. That's the same thing as 0.47. That's the same thing as 0.53, right? The old schools is turning percents into decimals. The decimal is what's important to us, and the decimal is what we're going to end up using in not only StatCrunch, but also the formulas. But remember, too, that what this means is 47 out of 100, right? If we turn that into, that's what a percent is per 100. We have the 47 out of 100. This is how many people occurred, right? How many occurrences we had that voted for Trump. Here is the total voters. And I know that some of the problems have you actually write that ratio of, here's how many correct orders there were. Here's how many incorrect food orders there were. You need to add those up for the total and then put how many mess ups there were over the total and how many non-mess ups there were over the total. And we want to keep in mind all three of these. All three of those are important. Those aren't just numbers that we see, and I know they convert back and forth quickly in the MyMathLab, the view example, but here's the idea of what a confidence interval is. And I know that they give us the weird formula, the E, that's the margin of error. And what they have is Z alpha over 2 times the square root of PQ over, and I think our book uses it as P hat and Q hat. I've seen it as P bar and Q bar, depending on what kind of resources you're using that. But again, that is your P, success, which means the event occurred. That is your Q, failure, which means your event did not occur. Those two need to add up to 1. That needs to be your 100%. This Z, and I know that we're probably getting used to this now, whenever we see the 90%, remember that Z is going to be your 1.645, and this was coming from that Z table that we're used to. Whenever you see the 95, that means your 1.97, 1.96, excuse me. Trying to go off these on memory. 99 is your 2.575. And remember that those are permanent numbers. And whenever you see one of these three numbers, just think of the one that associates with it. But you can crank that through in a formula. I'd be plugging in, okay, 90% confidence interval, that's 1.645. I'm going to punch in my 0.47. I'm going to punch in my 0.53. And remember, your sample size, in this case, I said 100 voters. I'm kind of making these numbers up. You can punch this in on your calculator. You don't want to. I'm going to show us in the next video how to use this on StatCrunch. But here's the idea of a confidence interval. The confidence interval is us creating an interval, like a bookcase, from one number to another number. How confident are we in where the population is actually going to be? You start with what's called your point estimate. The point estimate is the middle of the interval. It's kind of your starting point. It is your best guess at what's going to happen. If our data showed 47%, that could be right, that could not be. This is a sample. Maybe we were asking a different population or a different sample size that may be skewed more one side or the other. That is going to be the middle, our starting point. And we're looking for how low can we likely get? How high can we possibly get? So what we're going to be doing is adding and subtracting our margin of error. We punch those in. We're going to, again, expect that if this is a decimal, this 0.47 that we're using, the 0.47, 0.53 that we're plugging in, we're going to expect that to be just a little bit above and a little bit below, right? Think of that as 47 cents for right now, right? Always try and think of those as money because it's something we're more used to. Say we crank all of this in here and say we get a 0.06, expect a number like that, right? Where this was 47 cents, this is 6 cents. What we're going to do is add that 0.06 and we're going to subtract that 0.06. You start with your point estimate. You add your margin of error, you subtract your margin of error. You would get a 0.53. You would get a 0.41. Remember that those are percents. This would mean 41%. This would mean 53%. What this means, and this is the overall idea, right? We crank out these numbers. These numbers are something to come into a calculator, and it looks like hieroglyphics when we look at on our notes and on our My Math Lab when they're showing us. But what this means is we can be 90% confident, or whatever confidence level they give you, that the population that come November, 41% to 53% of the voters will actually occur. And that's what we're looking for, is the lower bound and the upper bound for what we will allow, what we are confident that the population will display. And that's what the proportion, again, a proportion must be a P and a Q, probability of event occurring, whether it's good or bad, probability of event not occurring, whether it's good or bad. Again, it doesn't matter. It's called success and failure. But again, plug and chug, point estimate, add your margin of error, subtract your margin of error. Lower bound, upper bound, done.